Sabal Khair students, good morning. Hope you all are good. And I'm going to start a series of lecture on certain chapter of class 11. So hopefully, okay. So first our topic of chapter 1 of class 11th is dimensional analysis. Dimensional analysis. Okay, this is our first chapter. In dimensional analysis, first I want to tell you about physical fundamental, you can say, or you can say base quantities. Okay, what do you mean by this physical fundamental or base quantity means? First I want to tell you we have 7 base quantities. The 7 fundamental or base quantities chosen in SI are called 7 dimensions of the physical world. Okay, so I will tell you what about we have 7 base quantities and what are they. Let's see. First is our length, and mostly it is denoted by L within bracket dimensions, so we just take like this. Next is mass, M. Okay, and next one is time, that is denoted by T. Next is current, that is A. Next is temperature, denoted by K. And then luminous intensity, denoted by CD. These are brackets, square brackets. And amount of substance, generally we deal it in chemistry, measured in terms of moles. Okay, so these are our 7 base quantities. What do you mean by base? Why this is called base? Because all other things can be derived with the help of these 7 base quantities. I will repeat these words again throughout the chapter. This is our 7 base, this is our pillars. For example, if I say we have 7 pillars, 4 pillars, so this is my base pillars. All other pillars needs a support. How strong your base pillars are will give strength to your whole building. So whole building's pillar depends on these base pillars. So your base pillar should be strong. Or in more terms, I want to tell you what all these things supposed to be, or we will talk about these in very detail. Don't worry, you will get all the concept as the lecture goes on. You will get all the concepts very clearly. I will give you more and more example. Okay, so this is your pillar. This is your pillar which give strength to your whole building. So fundamental block of the building. Let's take example. For example, velocity. Now you will ask why velocity is not your fundamental or base quantity. The reason is, what is the formula of velocity? Velocity is nothing but displacement upon time. I'm correct? Look, time is my fundamental quantity. This is my main base pillar. I need this pillar. Other variables I cannot use for time. Time is time. I need a separate pillar for time. I need a separate pillar for my length. Only length. Why velocity is not my one of among my these 7 quantities? The reason is displacement. What is displacement? You are talking about from this point to this point. Suppose this is your house and this is your school. So what you are talking about? You are saying to me, I'm going to school from my home. So what you are talking about? You are talking about nothing but length. So displacement can be written in terms of length and time in terms of seconds. I'm correct? So velocity dependent on among my 7. This length is one of my 7 pillars. seven fundamental quantity, time in seconds. Okay, I'm sorry. Length and time. Time is again one of my seven. Among seven, I have one quantity, that is time. Okay, so velocity can be derivable. It is derivable. It is just derivable from my base. What is my base? Base quantity. Okay, so velocity depends on length and time. Whatever formula is, at last you have to just break that formula, and at the end I'm sure you will end up only in these seven fundamental quantities. Let's take one more example. Acceleration. Yes. So we know that what is acceleration. Let's not talk about the definition of acceleration. What my aim is, again, why acceleration is not a physical quantity, why we don't give it as a base quantity. We know that acceleration you just have to break up into at the end you will end up only in these base quantities. Let's write the formula of it. What is acceleration? Acceleration is nothing but velocity upon time. So what is it? Time. Again, we have a base fundamental quantity, we have time. So we don't have to break time, just velocity. What can we write instead of velocity? We can rewrite as, you know that velocity is nothing but displacement upon time. So displacement upon time, and it is already here. So time. What is displacement? Displacement is nothing but you are talking about length of something, right? So length into time square. So again, length is one of our base quantity, and again time. Okay, you can take any example if you want to. Let's talk about what about work? Work is something different. Okay, what is work? Work is nothing but energy, right? How can we write work as? We can we have a formula of work is as the force applied to the body into how much the body displays after applying the force, that is force into displacement. Okay, just what is for now, you know that displacement can be rewritten as in terms of length. Length is our fundamental quantity, so displacement is length. Okay, fine. What about force? How can we rewrite force as? Force can be written as mass into acceleration. Correct? Now mass is one of our fundamental quantity, base quantity. Sorry, this is mass. Okay, so now we are left with acceleration. In above example, I just show you how you can write acceleration as. So mass into L upon T square into L. So look, students, all terms are in fundament, or all are means you are breaking your work, your acceleration, any quantity of physics into our fundamental quantities. So that's why I said these are our basic pillars, these are our fundamental pillars. All other things are secondary, they all are dependent on our fundamental quantities. You can drive these, work can be derived from base quantity. Again, I proved it. See, look, this is our acceleration. You can't say acceleration can be as fundamental quantity. Why? Because acceleration, again, you can drive acceleration with the help of our fundamental quantity. Right? Now, our system, our SI system. Let's talk about one more thing. And then the whole thing I will just combine in a single table. Okay? SI system. This is my second topic. Our SI system is divided into two basic things, that is we follow MKS or we follow CGS. Okay, don't think it's a new term for you. I'll just show. Just have patience. At last of the video, at the end of it, you will get all the terms very clearly. Just be with me, okay? Don't worry. You know that in ancient times, what sometime if you went if you know from your if you have listened some stories from your grandparents, what they used to talk about, they used to say, when we went to the grocer's shop, we used to say we wanted 2 palms of flour or grain or some pulses or anything. So the palms, every person have the very length of the palms. You have a variation. Somebody has a this much amount of fees, somebody has big amount. So it's depend on the person, it's vary from person to person. Okay, so SI system is divided. SI system said no, we want international system, all things acceptable internationally. Okay, so basically we will talk about just two things, MK system and CGS system. MK system means mass, this is mass, this is meter, this M means meter, K means kg, and S means second. M means meter, K means kg, and S means seconds. What is our CGS system? C means centimeter, G means gram, and S means seconds. So basically what you are doing, these fundamental quantities you want to specify, you want to give the weight to your physical quantities. Okay, let me give you some examples so that you get better understanding of it. For example, if I say 3, might be some of you thinking, what does this 3 imply? 3 is just a magnitude. What I want from this 3, what I'm talking about. So basically your question is what I'm talking about, whether I'm talking about 3 kilogram, 3 liters, meters, what type of 3. It's just a magnitude, it could be anything. So let's say now I just specify you, I'm talking about mass. Now again the same question arises, this 3 mass. Okay, now from these quantities or acceleration, I'm not talking about acceleration, work, I'm just talking about mass. From such a large quantities, you get a one picture that what kind of 3 I'm talking about. I'm talking about mass. But again the question arises, is this fundamental quantities are enough to give weight to this 3? Are you getting something from this? Just you know one thing, that 3 is talking about mass. So what I mean to say, what I'm talking about, I'm talking about 3 kg, or I'm talking about 3 grams, or I'm talking about 3 milligrams. Nobody knows what type of mass I'm talking about, whether in terms of kg, gram, or milligram. So that's why I'm saying SI system gives weight to your physical quantity. They just raise your quantities, they raise your dimensions, the unit, the SI unit, raise your dimensions. For example, if I'm saying 3 grams, so you will just I say 4 grams. So you know that even if I have not said that I've talked about mass, how do you know I'm talking about mass? Because of the unit. You know that I'm talking about mass, and what type of mass? It is just 4 grams. So unit gives weightage to your, it gives weight to your fundamental quantities. Okay, so now what type of system we are following? We are following MK system. MK is our SI system. That is, M should be in terms of meter. For example, some student give me, my answer is 3000 grams, and some students say my answer is 3 kg. So all students, you know that both are same. I'm talking about the same thing. But since there is a variation, 40 students will, some students give me in terms of kg, some student will give me in terms of grams, even some are there who gives me answers in terms of milligrams. You know that 3 into 10 to the power milli is just 10 to the power minus 3. So of course 3000 and 3 kg both are similar, but some student will be in this term, maybe in terms of milligram also, maybe in terms of kg also. So why we are following different things? We just want one answer all 40 students should give answer in just one thing. So what I want such a system whose answers are only one, whose unit is one. So that's why it is advisable to student to just use SI system. What is SI system? SI system is nothing but your MK system. M should be in terms of meter, K should be in terms of kilogram, S should be in terms of seconds, because these are our fundamental quantities. I know you are talking about we have 7, so as we will study more and more, we'll get into all these things. You will get a clear picture of all of it. Okay, right now we just have to follow and means is SI system. And why we are using CGS system? Somewhere we use this. For example, in our laboratory we have a scale in centimeters. We use a small mass which is in grams. Okay, so that's why in laboratory when we go for practical we use such a centimeter, gram and seconds. When we have a small quantities, of course MKs can convert it to CGS and CGS can be converted to MKs. Okay, so CGS system and MK system we follow. Let's talk about with some examples. Let's take some example. For example, again just we took velocity. We will take 4 to 5 examples. For example, velocity. What is velocity? This is our quantity, some physical quantity. We are saying some physical quantity. This is our physical quantity. We just make a block of it, diagrams, or I mean to say just table of it. Look, physical quantities, we have so many physical quantities, but these are our base pillars. Remember, whole building and these are our pillars. So these are our pillars, 7 pillars. Okay, we end up to these 7 pillars only. Okay, fine. I just draw something so that you will get better understanding of it. Fine. Physical quantity. Next is, let's say, we will say formula or relationship of velocity in terms of our physical quantity. Right, physical means base, our base, this velocity relation with our base quantities. Okay, so I just write formula over here, and then dimensional formula, and last is our SI unit. Okay, fine. What is velocity? As you know, just velocity is nothing but what is velocity? I told you velocity is nothing but your displacement upon time. Displacement upon time. Okay, can we break displacement? Again, we know that displacement is nothing but length or upon time. It means length is L, correct, and T is time, correct. Now what is SI unit? We will use MK system, not CG system. Okay, so what is L? L can be in terms of what I told you just before. M means meters. It means I'm talking about length. This is my length. Kg means mass and T means time. Base quantities and its SI unit. Okay, this is my base. Look, I just want to tell you before we complete the table, just have a look in this also. Base quantities, we have base fundamental quantities. We have 7, of course, but we just talk about 3 right now. Later on we will, as we goes on, we will study more and more. Don't worry about it. Just have a look of this. M means we have mass. Okay, mass SI unit is kg. We will use mk system, so mass kg. Length would be in terms of L, and time will be in terms of second. Correct? So it's what denotion we use? We use m, length, and time. Correct? Kg, length, and seconds. This is my SI unit. Fine. When we use mechanics, like our Newtonian mechanics, where force is applied, torque is, we just have force, displacement, and this type of equations. Okay, mechanical quantities. So generally we use m, mass, length, and time. When we talk about our current, we will use ampere. When we use our thermodynamics, that's a different SI unit. In current also we have ohm, Henry, magnetic flux unit, and etc. So many. So okay, just now we are talking about Newtonian that mechanics, mechanical quantity that generally use length and breadth, that generally use mass, length, and breadth. Okay, fine. Velocity is equals to displacement upon time. Length, displacement means length upon time, that is L upon T. What is SI unit of length? SI unit of length is meter. I'm sorry for this. SI unit is meter, and time will be in terms of seconds. Okay, let's take one more example. Density. Can we take density? Yes. What is density? Density is nothing but your mass upon volume. Correct? Mass. What is this mass? Mass is our fundamental quantity. Okay, fine. What about volume? Volume is nothing but your can be written as L into L into L. Correct? So it means mass m, L into L into L. Correct? That is L cube. This is nothing but your m upon L cube. Correct? So can we write SI unit? M means mass will be in terms of kg. L means length will be in terms of meters, that is meter cube. So SI unit of density is kg per meter cube. SI unit of velocity is meter per second. Let's take one more example that we took just before, that is of work. Okay, any quantity you can drive. Work, again our physical quantity. What formula does work has? Okay, work can be written as force into displacement. Correct? Okay, fine. What is force? Force is nothing but your mass into acceleration, and displacement in terms of length. Correct? Again, mass, and mass is our basic fundamental quantity. L is again our basic. So acceleration we need to change. We need to end up in our basic fundamental quantities. Okay, base of fundamental quantities. So what is acceleration? Acceleration is nothing but velocity upon time. Remember, displacement upon time, L upon T square. Okay, so can I write directly L upon T square into L? So what type of dimensions we are getting? We are getting m, L into L square divided by T square. Correct? Or can I write it like this? M, L square, T minus 2. Okay, what can, with the help of these, can I write SI unit? Yes, I can write. M will be, what is M? M is mass. Mass will be in terms of kg. What is length? Length will be in terms of meter, that is meter square. What is T? T will be in terms of second, that is S to the power minus 2. This is the SI unit of work in terms of dimension and in terms of SI unit. Okay. Look, students, if sometimes if you have an option Of course, this can be written as L T to the power minus 1, correct? Or meter per second, you know that. We don't have mass over here. Suppose you get various options like M0 LT minus 1, M2 LT minus 1, or M minus 1 LT. Which one is correct for velocity? Which dimensional formula is correct for velocity? So correct formula is this. Why? Because no mass is over here. So can you write it like this? M0, M something to the power 0 is nothing but 1. So it doesn't make difference if you write these dimensional formula as this. Okay. Now let's take one more example. Let's talk about our I remember one more quantity, that is linear momentum. Let's talk about that. Where should I write? Okay, can I use this page? Linear momentum. Linear momentum. Okay, what is linear momentum? Again, linear momentum as a formula is mass into velocity. And students, if you don't know the formula, if you even don't know the formula, don't worry. You will learn all the things as we move in our chapters. We have so many chapters. At the end of your 11th class, you will come to know each and everything. You will learn every formula. So don't get upset. Keep learning. Okay. I know this because I know all the formulas. Just keep going with the flow. Linear momentum is equals to mass into velocity. Again, mass is very good. M is mass. Okay, is velocity end up in our basic fundamental quantity? No. So we have to convert it. That is, you know that velocity is displacement upon time, and it is nothing but length upon time, or length is L and T is correct. So can I write it like this? L upon T. So what is my dimensional formula? What is my dimensional formula now? That is M L T minus 1, correct? Any problem? So M is mass, SI unit is kg, very good. L is length. Length will be in terms of meter, correct, and T will be in terms of second. So what is the SI unit of linear momentum? SI unit is kg meter per second. One more formula. I just want you to practice over here with me. One more formula. Let's talk about pressure. What about pressure? What is pressure? Pressure is your force per unit area. Wow. And remember, force is mass into acceleration. Area is L into L, yeah, length into length. Area is meter square, no, centimeter square, like this. So length into length. Again, length, mass, all are basic fundamental. Is acceleration? No. So we just have to just end up with our basic fundamental. Again, I am repeating same thing again and again, so that every concept will just you just get into your mind. So mass into what is acceleration? Acceleration is L upon T2. Length, velocity upon time, displacement upon time, L upon T square. L upon T square, and here we have length into length because of our area. Okay, all are our basic, all formulas we are here. Now mass, length and time. Can I write it in dimensional formula? Yes, I can write. Look, can I cancel it? L into L? Yes. So what I'm left with now, M L T square. Correct? Can I write it like this? M L to the power minus 1. It is plus 1 over here. When it goes to numerator minus 1, In denominator it is 2, that is t to the power minus 2 when it goes to numerator. Okay, now it is easy to write SI unit. Mass in terms of kg, length will be in terms of meter, time will be in terms of second. This is all. This we have lots of physical quantity, lots. It's a very short video, and maybe we have to elongate the video, and even then also we will not end up with our physical quantities. We have so many formulas in physics. Okay, this is the one thing where we need a dimensional analysis. We just have learned the fundamental quantities and our SI unit. Now I want to drag your attention towards the very next topic. So is it the only use of dimensional formula or our SI unit? That is one use of dimensional formula is we can easily find SI unit with the help of our dimensional formula. That is the one use. Is it the only use? No, there is one more use, and you will amazed with. Many of today's life we have a Google. When we want how much there's 1 foot equals to how much in terms of inch or meters. When we want to convert certain quantities, we just type it in our calculator, or we just use our Google, and we can easily switch from one hour unit dimensional to another unit dimensions. Okay, you will easily get the formula that 1 meter is equals to 100 centimeter, or if you want 10 centimeters, so it is equals to 10 into 100. 10 meters in terms of centimeters, so 1 meter is equals to 100. You know that in 1 meter we have 100 centimeters, so how much centimeters will be in 50 meters? So 50 meters equals to 50 into 100. Correct. These conversions are so easy in today's life, but what if is dimensional analysis? With the help of dimensional formula, you can easily derive SI unit. Not only this, but you can easily go from one system to another system. Easily you can switch. That is from MK system. You can easily switch from MK system to CGS system, or from CGS system to MK system, or any other system, whatever you want. This is such a great thing. So let's come to this topic and how we can easily switch from one quantity to another quantity. Let's go to this. First of all, I just want to tell you one very simple formula. N1U1 is equals to N2U2. Just remember this. What is N1 and N2? They are just a number, magnitude. What is N1 and N2? They are just number or magnitude. For example, you know that this is N1 and this is your N2. So 1 meter, you want to convert 1 meter to 100. 100 is what? Is your N2. Okay. So similarly, this is your N1 and this is your N2. This is your N2. Okay. What is this U1 over here? U1 is meter, one system, and U2 is your centimeter, another system. So you can easily switch from one system to another system. Okay. Let's take how we can do this with the help of examples. U1, what is U1? First we learn the formulas and then we will have numericals. Okay, U1 is equals to M1 because we always use MLT, ML and T. We are dealing with mechanics. Okay, only MLT we are dealing right now. M is mass, very good. L is length and T is time. This is for one system. Okay, and let's say it A, B and C. Let's say some powers, like we have powers, -1, -2. So these are just powers. We don't know right now, we don't know anything. What is U2? Let's say U2 is our another system in which again we have MLT, correct? And this is another system, so we are using ML2, and again power A, B and C. Because these certain power is converting to these powers, so they must be equal. Okay. So this is your basic formulas, and I know you are not getting this right now, but we will take an example and then you will get a concept. Just take a very simple example. How much 1 Newton, what if I want to know how much is 1 Newton. I want to convert 1 Newton into dyne. I don't know how much 1 Newton into dyne is. I don't know. Means how much 1 Newton is equals to how much dyne. I don't know. So can I use this system, dimension system, help me in finding the answer of this? Yes, we can. What is Newton? Newton is the unit of force. You remember force unit? Where's force? We didn't drive force right now. Okay, no, don't worry. Newton is a unit of force. So just Newton. Force is our physical quantity. Okay, force. What is force? Force is nothing but mass into acceleration. Fine. Mass. Acceleration you have to convert. Okay, so acceleration is equals to, can I write m into L upon T2? Remember, again, same thing. Acceleration, velocity upon time, displacement, L upon T2. Fine. This can be written as mlt minus 2, since it is in denominator, as it goes to numerator, power minus 2. Very nice. Fine. Can I write it SI unit? What is SI unit? SI unit is mass in terms of kg. L will be mass. L will be in terms of meter, and T will be in terms of seconds. Okay, so force SI unit is SI unit of force is equals to kg meter per second square. Fine, it is also good. But what about Newton? This quantity, this is equals to kg meter second square is equals to 1 Newton. This is the definition of 1 Newton. This is our Newton. Okay, so I want to convert 1 Newton into dyne. Okay, now this is my SI system we have. In MK system we have what was our formula? Our formula was N1U1 is equals to N2U2. In starting, I'm just going in detail, and later on we'll just skip these steps and start to do with the shortly we will do it. Okay, so what is N1 here? N1 is equals to 1 Newton. Since I want to know how much 1 Newton into how much times, how much 1 Newton into dyne. So what is my N2? N2 I don't know, because I don't know number of dynes. What is N2? N2 is number of dynes, correct? Now what is my M1? N1, and you remember the formula. The formula is N1 U1. What is U1? M1 L1 and T1. Okay, so what is my U1? U1 is equals to M1 L1 and T1. Remember this M1 L1 and T1, and to the power A, B and C. So what is my U1 here? N1 is 1 Newton. So let's look about M1. Compare this one with this one, this equation with this equation. So here you are getting, what is my M1? M1 is equals to how much? I just want 1 kg mass. How much is my length? Length is just 1 meter, and time is 1 second. And comparing to this, when you compare 1 with 1, what you will get? Mass is just 1 kg, length is just 1 meter, and second is just 1 second. And now compare this with this, B with this, and C with this. Okay, so what you will get from equation 1, compare equation 1, I should write it to a is equals to here a, and here a is nothing but 1, and what is b? B is equals to 1, and what about c? C is equals to minus 2. Correct? Here c minus 2, b is nothing, here nothing is 1, and m is nothing but 1. So you are comparing a with 1, you are comparing 1 and 2 because we have 1 Newton over here. Okay, fine. So I just want 1 kg mass, 1 meter and 1 second. Okay, similarly in U2, what is my U2? U2 was M2, L2 and T2 with same measuring A, B and C. So can you tell me what is my M2 and A2 and M2, L2 and T2? So here is again M2. I just want M2. What is this? Look, dyne is in CGS system, correct? So I just want this to be in CGS system. This is my CGS system, correct? So M2 is mass. I just want to convert 1 kg into 1 gram. So here is 1 gram. I want length of 1 meter. So in this I want it in terms of centimeter. So it is in terms of centimeter. And I want time in second in CGS and in MK system same. So I want T2 is 1 second. Okay, fine. Now I don't know the value of A, B and we have A, B and C like this. I don't know the value of A, B, C. I know the value of ABC also. A equals to 1, B is equals to 1 and C is equals to minus 2. So okay, let's get into the procedure. What we have N1, U1 is equals to N2 into U2. Formula is, what is my N1? N1 is 1 Newton. What is my U1? U1 is 1. Okay, so U1 is I just write it down in the same form. M1, L1 and T1, this is A, B and C, is equals to N2. N2 I have to find out. I don't know the value of N2. So this is M2, L2 and T2. A, B and C. Correct? Now students, I want to find the value of N2. So just take this here. So here is 1. Here is my M1, M1, L1 and T1. This is my A, B and C. Okay, divided by M2A, L2B and T2C. Correct? And this is equals to N2. So can 1 multiply by anything is same number. So M1 upon M2 can be written as A. L1 upon L2 can be written as B to the power B. T1 upon T2 to the power C is equals to N2. Correct? I know the value of M1. M1 is equals to 1 kg. 1 kg. Write it down. What is my M2? Are you getting my point? I want to convert MK system. This is my MK system. I want to convert 1 Newton into dyne. That is MK system to CGS system. Okay, just a different thing. It's like a same thing. 1 meter is equals to 100 centimeters. So that 1 meter is in MK system and centimeter is in CGS system. So I just want how much 1, and I know I just want to know the value of 1 meter. So it is equals to 100. So I just want 100 here. So this is my N2 in this, and here it is my N1. Similarly, I know it is 1 Newton, so N1 is 1. So how much Newton into dynes? Okay, I want to find the N2. And M1 is in grams, kg, and M2 is in gram. That is 1 gram. 1 kg to 1 gram. Length, can you find length? Length is length is 1 meter, and here is 1 centimeter. 1 meter to 1 centimeter, and here's B. And T1 to T2, T1 is again 1 second and here is 1 second, and to the power C is equals to N2. Do you know A is equals to 1, B is equals to 1 and C is equals to -2? So I think I should write this. Now look, kg and grams. I know 1 kg is equals to 1000 grams. And what is the value of A is 1. I know 1 meter is equals to 100 centimeter. What is the value of B? B is 1. And second to second we can cancel out. And C is nothing but -2 is equals to N2. So grams to grams cancel, centimeter to centimeter cancel, and this one all cancel. So this I left with 1000, multiply, all multiply in between, okay? 100, 1 to the power -2 again give you 1, okay? So this is 1 2 3 4 5, that is 10 to the power 5, and 2 is 5. So 1 Newton is equals to, I want this number, so this number is 1 Newton. 1 Newton is equals to 10 to the power 5 dyne. Okay, so N1 U1, N1 is, this is my N1, this is my U1, this is my N2, this is my U2. So I just want to convert MKS into CGS system. So video is getting longer quite now, so I just want to stop over here. In next part we will practice more formula on this. We will practice more dimensional formula on this conversions, that is from MKS to CGS system. So please stay with me, watch next part also, watch the whole series also. Thank you so much. Khuda Hafiz.